Some topics I like to talk to you about are built-in functions, the print function, basic data types, and conditional logic. And these are what we'll focus on today. So we just saw that in spreadsheet software, there are a number of provided built-in functions. And so in Python, we have some built-in functions as well. And where are they coming from and what are they? I'd like to draw your attention to this link that I've shared in Slack related to built-in functions. You'll see it in today's agenda. So in Python, here are a list of built-in functions. Each one of them will be used for a different purpose. We might not use most of them or all of them. Each one will require its own set of unique parameters or input arguments. And so in order to learn more about how to use any one of these functions, we will consult the documentation for that function. The first function that I'll introduce to you more formally that we've already started using is the print function. So let's take a look. Here we see there is a provided print function. So what is it about? Maybe the docs might help us understand the print function a little more. Maybe they'll help us understand better the parameters that this function accepts. However, in this case, I think these docs are pretty bad. As we move on and deal with other libraries and packages, the documentation will get a lot better. So to supplement some of the docs that we see here for official Python stuff, that's why I'm providing all of those examples to you in the Python language overview notebook, in the data types notebook, and so hopefully that can complement what we see here in the docs. We use this print function to output some kind of message. And so we took a look at this already last week with our Hello World notebook, where we printed some kind of textual message. So I'd like to encourage you to try printing a few things now. Within our built-in functions section here, you can create a number of code blocks for yourself. And let's just start by printing some kind of textual message like hello world. And then running the cell. Whatever we print, we will see outputted when we run the cell. That's basically what the print statement does. It's used for logging and output and display purposes. Cool. I'll also provide a link to this built-in functions just so we can get back to it if we want. And we could explore other built-in functions, and we'll use more as time comes on, goes past. So I guess, let me just move this cell down into this area about print function. So most functions will require a specific number of parameters in a specific order. But the print statement, the print function is kind of special in the sense that we can pass any number of comma-separated items to it. So it's unique in that way. It's very flexible in the parameters that we pass to it. But if we want to print many objects, we'll separate them with commas. For example, print one string called hello, comma, another string called worlds, and maybe comma. We can also do numbers, and it's all good. What do you notice happens when we introduce a comma into our print statement parameters? Any visual observations that you could make about what that does? Exactly. The comma here introduces a space character into our printed outputs. So here we do see a space between hello and world, and another space between world and 10. So as a byproduct of printing many comma separated things, we see the output has a space where each comma is. We'll return to some techniques in a few minutes about how to assemble single textual values called strings, but I think that's good enough for now. So here you see us starting to pass in different types of objects into our print statement. Like, sure, we could pass in this textual method surrounded in quotes. That's called a string. We could also pass in numbers like we've been working with, like the number 10, and that's all good. What you should know is that in Python, we have different data types. So as we try to model real world concepts in objects in our programs, we have some options about what data types to use. Some common data types are the following. I'd like to draw your attention to the basic data types notebook, and we could see an example of some data types here. So I'm just going to copy this code from our basic data types overview into our in-class cheat sheet. And now let's explore these data types or identify them a little more. So here you see we're starting to use another function, a built-in function called type. And if we pass an object into the type function, it will tell us what data type something is. We'll see in a minute why data types are important and the difference between data types. But just to get started, we see that if we would like to represent textual messages in our program, we can use a data type called a string to do that. If we want to use a string, our message must be encapsulated in quotes on both sides. And it's the quotes on either side that makes this object a string data type. And so that's what allows us to print textual messages like this. Hello. We'll see as a string data type. Even if we have some kind of numeric looking object, if it is encapsulated in quotes, like there's 100 inside the quotes, that's still a string because we have these surrounding quotes. So if we actually want to do some math with some numbers, we will treat those numbers literally without quotes. And now when we ask what data type we're using here, we see whole numbers are integers. And if the number has a decimal component, it's called a float. But regardless of whether we have an integer or a decimal, we could do math with these objects. All right. So the other data types that we'll focus on today as well are Boolean values. There's only two Boolean values. One is true with a capital T, and the other is false with a capital F. And these are the opposite of each other. It's on the basis of this assumption that truth is the opposite of false. That's how computers can even work in the first place. If anyone's heard of Boolean logic or binary logic, ones and zeros, that's the basis for how computers do all of their work. It's all about comparing the difference between truth and false. And so unlike other disciplines and current events where truth might be somewhat subjective, the nice thing about programming is that the truth is universal and there's no question about what is true and that it is opposite of false. And so true and false are our Boolean values. When we do conditional logic, even like that quick if statement we started with in spreadsheet software, we started dealing with the concept of true versus false. In spreadsheet software, we said if some condition evaluates to true, then let's return some kind of message. Otherwise, if that's not the case, then we'll return some other kind of message. So we already started dealing with this foundation of Boolean logic and what it means for true to be the opposite of false. Those are the main data types that we'll focus on with the remainder of class today in our exercise: strings, numbers, and Booleans. However, what you should know too is that in the near future, we'll be dealing with other types of variables as well. There's a specific variable or object called none with a capital N. And this represents a null value. It means there's an absence of the value. So if you're familiar with NA values in spreadsheet software or null values in SQL and databases, that's what we're dealing with here. We won't deal with none that much. So we can feel free to move on right now. But you should know that there's a way of representing a lack of a value using this none with a capital N. So again, true, false, and none, there are no quotes here because these literal words are reserved words in Python. The final two types of data or types of object that we will explore starting next week in more detail. One is called a dictionary, which has what's called key value pairs. It's a container for multiple items, but we'll get more into the details next week about these container data types, the dictionary and the list. So we will revisit dictionaries and lists next week in much more detail. So we can feel free to just kind of know that these data types exist for now, but we will come back to them in a lot more detail. They might look a little intimidating right now, and that's all good. We'll come back to these. If you're feeling somewhat good so far with like Booleans and numbers and strings, then hopefully that's the goal. So let's take a brief moment to explore what we can do with each of these most common data types. We will focus on strings and then numbers and then Booleans. And when we focus on Booleans, we'll introduce if statements, and then that will lead us into our exercise of the day. So let's focus on some basic data types, specifically strings, numbers, and Booleans. So I think numbers are probably the easiest to start with. We already intuitively began performing arithmetic operations with numbers last class, like print 2 plus 2. So hey, multiplication, division, all these things, we have arithmetic operations available to us. What if we do something like this? Five times 5. And then we print 2 plus 2. Why didn't we see the result of 5 times 5 here? Quick recap, I guess, or what do you think? We did a multiplication here, 5 times 5. We are expecting 25 or something. We also did addition, 2 plus 2. When we run this cell, we see the 2 plus 2 result. Why don't we see this 5 times 5? Someone who I haven't called on yet. Exactly. If we want to actually see the results of some kind of operation, we'll have to print it. You'll see we didn't print 5 times 5, so we don't see it later. Here I'm starting to also use comments to comment out a certain line. Like now we are printing 5 times 5. So we do see it here. All right, that was more of a question about the print statement. The other thing you should know, though, is that if 5 times 5 was the only and last thing that we do in a given cell, if it's the only thing, or especially if it's the last thing in a cell, we will see the output. And that's just like a weird byproduct of collab. Like if we print 2 plus 2, and then later just evaluate 5 times 5. What you should know about collab is that if it's the last thing in a cell, you might be able to omit the print statement. Collab will just print whatever is evaluated last. And so that's like a byproduct of using collab. If you want to be safe about this, just print everything. And there'll be no question that your results will come through wherever they are in the cell. That lesson was more about how code cells work in collab. If we try to do something first and we don't print it, we won't see it. But if we do that thing at the end of a cell, we do. It's kind of weird, just some pattern to get used to. Yeah, well, how much does spaces matter here? There are times when spaces matter and times when they don't. Times when they don't are when we're doing like math or doing operations of multiple things. Here you see it's equivalent if we were to print 2 space plus 2 versus 2 plus 2 without spaces. That's equivalent in this case. And so that's one example of some leeway we have with spaces or not. What you'll notice though is when we're invoking a function using a trailing parenthesis, I think that's a case where we do actually need no space between the function that we're using and that parenthesis. So there are some times where it matters. There's some times where, oh, I guess it still works, but that's not good form. Let's try to make sure there's no space there. Another way you could try things out is like try it and see if it works or not. And you'll see some patterns of when there is certain syntax that we'll need to use and when we have more flexibility. But when we're setting variables and doing math, we can use spaces or not. So just one more example of this. We haven't really used variables yet, but if we say x equals 5 and then print x, that's all good. We did x here, space equals 5, but we could also do something like y equals 10 with no spaces and then print y, and that works too. Cool. I appreciate that question. It helps us be interactive. It helps me answer your questions that are in your mind. All right. So numbers, hopefully that's not too bad so far. Questions about numbers before we move on? All right. So far we were doing some simple addition with numbers and that's all good. 2 plus 2, that's 4. All right, cool. Now let's start working with textual data known as strings. So again, if we want to print some kind of message like there is construction outside, we encapsulate that entire message inside quotes. And that's the way that we represent textual data in our programs. We can the same way store textual message in variables. Maybe we'll call this one message equals this kind of thing. And then print the message later, that's all good too. We will commonly, the thing that we'll do most often with string data types is concatenate them. Does anyone know what concatenation is about? Has anyone done concatenation in spreadsheet software? Raise your hand. Exactly. We're just going to literally join together 2 textual messages. So in spreadsheet software, if we have like a word here like hello, and then a word in another cell like world, we can concatenate those together in spreadsheet software using a equals concatenation function, concat or concatenate, in which case we'll just choose the values that we want to join together. And in that case, we see these values literally just smushed together. And that's string concatenation operation, just joining some things together. So often what we'll do is we will join strings together to compile a larger message, even if there may be a variable or number involved in our message. In Python programming, the way we perform concatenation is by using a plus operator. So we could say like hello plus world. And that's going to give us this single string, hello world. And surely we could print that as well. If we wanted to introduce space characters in here, you see they don't get introduced by default. So what we might need to do instead would be like add a space character there at the end of our first string. Here we're dealing with like literal space characters. Alternatively, we could add it at the beginning of our second word, and that works as well. Alternatively, we could model a space character with its own kind of like string like that, and that's all good too. So here we're concatenating many values together using the plus operator. So that's something we'll do very commonly. Now, let's talk about why data types matter. So far, we've been doing math with numbers. Oh, yes. We've been doing math with numbers. And we started doing this string concatenation operation with string data types. But in both cases, we're using this plus sign. So if we are thinking that we would like to do some math, like print 2 + 2, that's all good. And if we are thinking we would like to do some concatenation, that's all good. The string version of number 2 concatenated with the string version of number 2, what could we expect to see when we print this right here? 22, yeah, like a string textual version of 22. So that might be a little weird. We're using the same plus sign operator in both of these cases. But depending on what type of data we're dealing with, that same operator will do a different thing. So when we're dealing with numeric data, it will perform addition. When we're dealing with textual string data, it will perform concatenation. So if you weren't sure about what data types you're working with, and if you try to do something like this, print number 2 plus string 2, what do you think we'll see when we run this? What are we going to see, 4 or 22 or something else? Let's try it out. We run into an error. Python is like, I'm not sure what to do there. Unsupported operand types for the plus sign operator, integer and string. In other words, we ran into a type error. There's something bad or wrong about the data types that we're using here. Maybe the plus sign operator is not meant to work with a combination of, on one hand, a number, and on the other hand, a string. Should it be doing math or should it be doing concatenation? It doesn't know, and that's fine. This illustrates the example of why knowing what data types you're working with is so important. It may be clear here with these numbers and strings, one has quotes, one doesn't. But later, when you're working with any variable, if you get some kind of error, especially one that you're not expecting, I would encourage you to check your data types and double check, well, what data type am I working with here? Often you'll gain clarity about what the mistake is. Also here for the first time, we're seeing that we ran into an error. You'll run into errors all the time when you're programming. The initial reaction to an error might be subconsciously to get closed off and maybe even a little stressed out. Look, it's in red. It's stressful, right? But if you can try to take a step back and understand that with the error messages, they're at least trying to help us out, trying to give us a hint about what went wrong and how to fix it. So when we read the actual error messages, that might be very helpful in at least understanding what's going on and why. So I'll just comment this one out. We ran into an error here. Oops, hold on.
And it was a type error, an error related to the data types that we were using. All right, cool. So that's numbers and strings, string concatenation, and why data types matter. Questions about that before we move on? All right. So we have about a little more than 15 minutes left. We will conclude by talking about if statements and Booleans a little more. So we know that our Boolean values are either true with a capital T and or false with a capital F. And they are the opposite of each other. Different ways of comparing variables in these comparison operators. The double equal sign says, hey, is what's on the left equal to what's on the right? Question mark. And will result in either true or false. We also have some numeric related comparison operators that you're already familiar with, greater than, less than or equal to, stuff like that. So let's briefly take a look at these comparison operators. With Booleans, we can ask, is true equal to false? It's not the case that they're equal. In other words, is 2 plus 2 equal to 4? Yes, it is true that those are equal. So here with the double equal sign, we're using it in the following way. You can interpret it like this. Is what's on the left equal to what's on the right? Question mark with that double equal sign. Here we're not doing variable assignment, which takes place with a single equal sign. So we can always say x equals 5, and that actually stores the value of 5 in the variable x. That's not what we're doing here with this double equal sign comparison operator. This double equal sign comparison operator is something different. So we could say, is x greater than 4? Question mark. And we will see true or false as a result. So this is variable assignment using single equal sign. Oops, and then this is like is x equal to 4? This is comparing using double equal sign. So it is false that x is equal to 4 because it's 5. All right. So there we're just using that double equal sign. Is what's on the left equal to what's on the right? And it's different than using a single equal sign. We use that for variable assignment. So we also have these other operators like greater than, less than. I encourage you to explore them. One final operator to take a note of is the not equals operator. So if we say is x exclamation point equal to 4, this exclamation point equal is the opposite of the double equal. It's the not equals operator. And so it was false that x was equal to 4. They are not equal. Is x equal to 4? Nope, false. Is x not equal to 4? Yep, that's true. They're different. Is x greater than 4? Yep, that's true. Okay, hopefully that makes sense so far. Questions about this? All right. So we've talked about comparison operators as well. Just the most common ones that we'll use are double equal sign, and its inverse is the not equal sign. Awesome. And so what you see here is that this starts to form the basis of using conditional logic. Well, if x is greater than 5, maybe we'll do one thing. But if that's not the case, we'll do something else. So we'll conclude. The last topic we'll focus on in class today is taking this concept of Booleans and comparisons and introducing some if statements, some conditional logic. So in spreadsheet software, we saw that when we want to do a if statement, we need to think about 3 parts of it. The first part is some kind of expression. this logical expression will result to either true or false. And then depending on whether it's true or not, we'll also supply some things to do in each case. So in spreadsheet software, the if statement is actually a function, but in Python, the if statement is a statement and it looks a little different. There's no parentheses involved. So let's practice some if statements in Python now, and this will prepare you to do our exercise for homework and bring it in for next class. So the way that if statements work is like, let's say x equals 10. And so at the very most basic level, we can just use the if operator and then supply some logical condition like this. If, and then some kind of placeholder. If some logical condition, colon, enter, indent, do something. So this is kind of like our template for an if statement. We start with the word if, and now we'll supply some logical condition, and then something to do if the condition is met. That's the simplest kind of if statement we can do. If x is greater than 5, colon, enter, indent, print, yup. And it is the case that x is greater than 5. So that's the only reason why we reach the indented line of code. We're starting to now introduce the concept of scope. Regardless, if we print something on the left margin, like the bottom, we'll always reach that. So this is not part of our if statement, it happens afterwards. So Python's going to be like, all right, I see an if statement. Let me evaluate this logical condition. If it's true, only then will we execute the code indented inside. Otherwise, we won't. And so what that looks like is this. We can do a separate if statement here. If x is less than 5, colon, enter, indent, print, less than. Or maybe if x is less than 8. I'm just making it different here. We ran this cell, but we don't see less than. Why is that? Ideas? You see yup and bottom, but not less than. So what's going on there? Yeah, exactly right. Only if this condition is true will we reach this indented line. Since the condition is not true, we never reach this line. So if statements introduce some kind of conditional logic into our program, some of the conditions might not be executed. And at the simplest level, all we need is a single if clause in our if statement. However, with spreadsheet software, you also know that we have an else clause, so we can do that too. So another version of this using a single if statement is like, if x is greater than 5, we'll do something else. In all other conditions, maybe we'll just print like nope. So here we see a similar kind of thing. X is 10. We reach our if statement. The program sees some condition, some logical expression that gets evaluated. Is it true or not? In this case, it is true. So that's when and only when we reach line 4 and we see it printed. It wasn't the case that that this else clause is triggered, so we never see no. So it's possible for things to not get reached with our if statement. Does that seem okay? Finally, we can always specify a number of different elif clauses. So in spreadsheet software, you might need to do like a nested conditional. But in Python, we can introduce any number of elif clauses in the middle. So you saw only the if clause was necessary. The else clause will catch everything that doesn't meet the logical condition. But if we want multiple conditions, like if X is greater than 100, print, yup. If that's not the case, Python's gonna try to move through each one of these clauses one at a time until it finds its way out of this if statement. So, what do we think what do we think we're gonna see here when we run this cell? Thoughts? In this case, it's not common that we would put two conditions in here, but it is valid for us to do so. Let me change this up a little bit. Like if X is equal to 10, maybe we'll just say if X is greater than 2 here, greater, I don't know, than 2, equal to 10. What are we gonna see here? Yeah, let's take a look. Let's take a look. How does this if statement work? We only see greater than 2. It happens to be the first clause that was triggered. There's only one way out of an if statement, even if multiple conditions end up being true. The first one that's true will get triggered and then we'll exit to the bottom. So X is equal to 10. All right, we have an if statement. Okay, we have a logical condition. Let's evaluate. Is 10 greater than 100? That's not the case, so we never reach this part. We never reach line 4. All right, let's keep on moving, says Python, through this if statement. All right, we see an elif clause with another condition. Is 10 greater than 2? Yeah, that one is met. Okay, so now and only now will we reach line 6, which we see printed. And since this clause has been met, whichever clause returns, whichever one has been satisfied first gets invoked, and then we go to the bottom. So this is a little bit of a tricky one. You won't really have in many cases multiple conditions that will all be true. In general, you'll just try to capture all the different discrete cases, but maybe a tricky one here. All right. Generally, we'll just use if or if else as most of the conditional logic that we do. So yeah, question, go for it.
Sequence matters. Else before you.
Exactly right. The else clause, if you have one in here, must come at the very end. The elif clauses, you can have any number of them, 0 or more, and they go in the middle. And we have to start it with an if. And this comprises one complete if statement with multiple clauses. All right. So what I would like you all, so I think that covers if statements. We did a tricky example here, but I hope you can get the gist of things, at least with this example here. If you feel good with this one, I think you're ready. You're ready to move on to our exercise. Actually, we'll also need to know about some other kinds of operators before we move on. So I'll share with you those operators, and that'll help you do your homework for next class. So there's some other operators that we could use as well. They're called logical operators, and we could use them to form compound expressions. And, or, and not. Let's focus on and or. Using compound expressions. If we want to check two things like x equals 5 and y equals 10, we'll combine that kind of thing this way. If some condition is true and some other condition is true, then we'll do something. Or if some condition is true or the other condition is true, we'll do something. So here we'll say if x is equal to 5 and y is equal to 100, then and only then will we print yep. If we use the same logic with an or operator, let's see what happens. This is the last piece of the puzzle for you to work on your exercise for homework. So, does anyone guess what we're going to see as a result of running this first cell? X is 5, y is 10. We're going to ask if something's true, and then we'll see something or not, I guess. Thoughts in our last moments of class here? Yeah, we'll see nothing except bottom. It is not the case that both of these conditions are true. When we use the and operator, we're asking, are both of what's on the left and right both true? If they're both true, then and only then do we meet that logical condition. So and says both sides need to be true in order for the resulting expression to be true. It's not the case here that y is equal to 100, so we never reach the inside. All right, awesome. Last one to end class. What do we think we're going to see when we run this final cell? And we will see this one because with an or operator, either condition, if either condition is true, then the resulting expression is true. So even though y is not equal to 100, it was the case that x is equal to 5 and only one side needs to be true for us to reach the inside. We do see yep, and then we reach the bottom.